In this section, we will learn how to detect an image in augmented reality and its uses. These uses include using a photo as a position reference for a 3D model or using a photo as a trigger of one or more functions in the program. Okay, in this step, we want to talk about how we can implement an AR app with detection the 2D marker. For example, we want to appear something such as 3D model or video or other types of contents on a position of a 2D image. For example, this is our 2D marker. But it is really important to know that if you want to select an image for your 2D marker, it's better to be something powerful for detection. But how we can understand our photo is powerful for detection or not? For example, in this photo, we have some shapes and 2D elements on our image and text on our image. So these shapes and keen positions are very useful for detection. If I want to show you more better, you can see something like this. These points are those points for AR detection of a 2D marker. So if in our photo we have more points, so we will have better detection. Okay, come back to the Unity editor. So we will import our 2D image to our project with this part. Right click, import new asset, and then we will import any type of assets into our project. Then we will import a 3D model which we want to show to the on that position of the image marker. So, for example, which is animated drone, it's flying on air. As you can see, it has an animation, and this animation is loop. So we want to show this 3D model exactly at the position of the image marker after our image has been detected by our phone's camera. Okay, we will import this 3D model into our scene, and I already saved a scene. I called it 2D marker. Okay, and the next step we need to add an AR session origin. AR session origin. That's it. And the position has to be 0, 0, 0, for example. Okay. Now, the next step is we need to click on the AR camera and change these parameters. For example, clipping plans has to be 0.01. It is field of view, in fact, and the far distance can be 1000. Okay, and we need to add another option, another object. It's called AR session. It is the position of the marker. So with the AR session origin, we will detect the marker. And where is the marker? Inside of the AR session. So for 2D marker detection, we need to add a new component to the AR session origin. If you open the add component and write image, you will see AR tracked image manager. If you click it, you will import this component and add this component to your AR session origin. Then, as you can see, we have three variables. It's called serialized library, max number of moving images, and tracked image prefab. So in here, we need to add that object which we want to appear exactly the position of the image detected. So we will add, drag and drop the drone, our 3D animated model, into this option. And also, if we want to detect one image in one view, we will have to add number 1. If we want to add 2, 3, or 5 images simultaneously, we need to add 5. But for now, I will add the 1. The last step is we need to add a and come here to the XR part, reference image library. I call it to the photo library. Okay. In here, we will define, okay, what is exactly our photo marker. I click on add image and drag and drop this marker to here. The name of marker is Mecharithm marker, and the specified size has to be, for example, the real size of our photo. So, for example, I added 0.1 and keep texture at runtime if we want to resize our 3D our image. In runtime, it's better to be keep texture at runtime. The last step is we have to click on AR Session Origin, then drag and drop our 2D photo library to serialized library. Now it is ready for export an APK and test it in our device. So we need to click on File, Build Settings, and make sure we have company name and product name, and copy this product name in here, and also add our scene to the list of scenes in build. So we can do by drag and drop or and click on add open scenes. Then we will click on build and write the name of APK and click on save. That's it. Okay, after install our APK on our phone, we need to make sure it's completely done and come to the settings, and in here in the apps, we will click on advanced AR, for example, it's the name of my product. And in here, we will see permissions, the second option. We need to make sure our camera's permission has to be allowed to use by our application. So as you can see, it's not allowed right now. I need to click on camera and we say, okay, allow only while using the app. Now it is ready. I will close the settings and come here, open advanced AR. Okay. It works well. The animated 3D model of my robot appears exactly the position of the Mecharithm marker. Okay, it is the first step of photo detection and augmented reality with 2D photos. But in the next step, I want to use this marker not just for demonstrating the 3D model. I want to use this photo for adding some actions and some orders and tasks for my application. For example, I will say, okay, when I detect this image, let's to send an order to my robot. For example, rotate 45 degrees to right. when my camera detect this image, demonstrate this 3D model, and send an order to the robot, for example, stop the movement, something like that, or any types of orders and tasks. Okay, let's do this. Okay, now we want to make a system for find out when exactly the image has been detected by our camera. As you can see in here, we have AR Tracked Image Manager, but we need to have a script, a new script. I called it Marker Manager, and it will connect and join to the AR Tracked Manager, Image Manager, and try to track when the image has been detected by the camera. Okay, open in the script into the Visual Studio for scripting. Okay, let us get start from the beginning of our script. It need to has Unity Engine, Unity Engine.xr.ar foundation. It is important, and Unity.ui and Unity Engine.events. By default, your script already has this one, but if you want to use them, you have to write them in here. First, our variables. Public AR Tracked Image Manager. So it is exactly this script, AR Tracked Image Manager. We call it mTracker Image Manager. And the text from UI when we want to understand, okay, it has been detected. And also the Unity event when we want to say, okay, we detected it. What is the order? What we have to do? It is more than showing the 3D model, demonstrating a 3D model. In here, you can attach any script, any functions, and any tasks to your image detection system. In here, we will say on enable. On enable, it means when the camera works and try to detecting. And on disable, it means when our camera does not work and it's not the detection of the phone's camera is stopped. In here, we will plus equal untracked image change and minus equal untracked image change. Untracked image change is this function. It has a local variable. It's called AR tracked image changed event arcs. It is a default variable of the AR tracked image manager. So we will call it event arcs. And in here, when we for each, when our local variable tracked image is inside of that images have been detected, so it means our image has been detected by the camera. So okay, let's do anything we want. For example, I added the text, the UI text in here, the text equal this message, rotate object, or I don't know, for example, object detected, image object detected. And in here, we will call the Unity event order. So let's come back to the editor. Right. I've added the marker manager to AR session origin. It can be anywhere, but I've added it here. And first, drag and drop AR tracked image manager to this variable. Create an UI element from here. Game object, UI, and legacy, for example, a text. As you can see, it is here it's small, but I change the color to white to be better visible, and increase the scale, for example, something like this, and put it in the left top corner, something like this. Okay, and drag and drop the text into this txt file and txt variable. I want to change the default script string of it and remove it. Okay, and in here, so we can add any function we want. For example, when we detect the image, for example, I don't know, drag and drop this function, add this object, our robot, and I don't know, change the transform scale, for example, or something else. No, why not? Let's to create a new C# script, and we will call, okay, object test. Why we want to use the default functions of the Unity? We will create our own function. For example, we will call it public game object, and I don't know, public text txt, and that's it. We will create function public void change, no, show name. Okay, and we will say, okay, txt dot text equal object dot name. Let's return to the Unity editor, and in here we will see an object in here, object text here. Okay, and this one is text, and I want to add a new cube in front of our camera so we can see it anytime. Okay, I put the cube object exactly in front of the camera, for example, something like this, 3 and x3. So it is front of camera, but not exactly in the middle of our view. Okay, and I call it object, I don't know, object test. Okay, and air session object text to here, and in the order I say I want to call the function of this script for show name. So when we detect the image of our marker, we will see the name of this object in the text. And also I want to do something else simultaneously. For example, I want to void, public void create new object. But I want to create a new object with a delay, not exactly at that moment. So I create something else in here, void creation an object. Okay, and I will call this function by invoke. So inside of invoke, I can call it in with 3 seconds delay. It's perfect. what is going on in the creation of an object function? For example, we will have a new local variable object equal instantiate an object exactly like our cube. Okay, no, it has to be with another name. It's call it n something. Okay, and I will say nobj no a new object dot transform dot parent equal object dot transform dot parent, because I want to put our new object exactly in front of the camera as a child of the camera. So I will say the new parent object, new object's parent is equal this object's current parent. Okay, and I want to change the position of it as well. So no new object dot transform dot local position equal new vector 3. For example, the position of our cube was 3, 0, 3, so it can be 2, 0, 0, 3. Okay, and also the rotation of it can be different. Local lower angle and new vector 3, 0, 25, 0. And after that, text.txt equal mission is done. Perfect. Come back to the Unity editor. Okay. I will add this object here and call the function from object test of create new object. So now when we detect our image, we will demonstrate a 3D model of our drone. Then we will see the name of the object test in the UI element, and also after 3 seconds we will instantiate a new object beside of this cube, so but with a different position and different rotation. You can understand that you can do anything you want in here. These orders are just an example for you, so you can do anything you want. You can call any function you want. You can send the position. You can send another order. Okay, let's get an APK and test it in the real condition. Now we detect this one, as you can see, object front of the camera, and that's it. It is our first object, and it is our second object has been instantiated in this position, and you can see the rotation of it is 0, 25 to the right, and 0. Okay, and also mission is done. Okay, let's go to the next step.